Good morning, everyone, and welcome to the first panel of the technical sessions from 11 a.m. to 1 p.m. And the topic of this panel is passenger and goods transport, inland as well as coastal transportation. And the panel chairman is Mr. Hariraj P. After completing his B.Tech in Naval Architecture and Shipbuilding from Department of Ship Technology CUSAT in 2004, Mr. Hariraj joined GTR Campbell Marine Consults with its Trader Series bulk carrier project at Cochin Shipyard, which brought India to the international shipbuilding map after 3 years with the construction supervision and project management wing. He moved to Smart Engineering and Design Solutions Limited, the design wing of the group.
Good day to you all. Let me welcome you to this first panel of this DIMS-Lite version by Department of Ship Technology Alumni Society in association with India Boat and Marine Show. I'm Hariraj, a proud alumni of Department of Ship Technology. I work with SEDS, Smart Engineering and Design Solutions. We are a premier ship design company in India working on both commercial and naval design from their concept to production stage. I'm delighted to be the chairman of this panel. As already introduced, we have many eminent personalities in this panel from various sectors of this industry. As you all, I'm also eagerly waiting to hear from them their views on various aspects of cargo and passenger transportation through inland and coastal waterways. This is not a new topic. For many years, I have attended many seminars and have read many papers on various aspects of this particular topic, its advantages, its challenges, the regulatory requirements, the infrastructure requirements, and many like that. While it still remains the most cost-effective transportation means, the last mile connectivity and the adequacy of infrastructure to have year-round serviceability and all are remaining still challenges which we have to overcome to have a sustainable system with continuity in its service. However, for the last few years, we have seen consistent effort, concentrated effort from the industry, from the government to revamp and to utilize this capacity of the industry more and more. The government has now declared 106 additional waterways, which makes it a total of 111 waterways in addition to our vast coastline. We see large projects like the Kochi Metro transportation, Kochi Water Metro project getting into shape, which I believe is going to pave way for similar systems being developed at various parts of the countries. We see large projects like the Sagamala, the Jalmarg Vikas, which are looking at a total system development, which is connecting our waterways to the hinterland with rail and road and this multimodal connectivity. We are also seeing academia and industry gearing up to attend to this possible increase in demands by increasing the capabilities in terms of design like CFD and advanced analysis capabilities along with certain testing facilities. As you all know, our maritime industry is going through an unprecedented change. It was the change in fuel last year, and now we are all looking at decarbonization, and decarbonization is definitely driving how the industry will develop and how the industry will go forward. So when we look at, I could still say we are still developing this cargo and passenger transportation for inland and coastal waterways, we have to keep it in mind, because decarbonization is not just a thought, it is a necessity for all of us. So when we see how we can reduce this carbon footprint of the food we eat and the distance we travel, this water transportation can definitely play a huge role in that. There are so many new technologies being developed, like the usage of renewable fuels, wind energy, solar, LNG, hydrogen, fuel cells. So when we develop, we have to take into account all these aspects into our thought process and develop the industry. As said, I am eagerly looking forward to hearing the points our panelists have to say on this interesting topic. We have 5 presentations in this panel. At the end, we will have panel discussions with all the panelists sitting to answer your queries. During the presentation, we prefer not to have queries. You can always put your queries in the chat boxes. We will collect the queries, and at the end of the panel, we will attend to your queries and have a discussion. So, looking forward to a fruitful discussion on this panel. And let's start with Mr. Arun Sornapudi of Goa Shipyard. Over to you, Arun. Thank you.
Good morning, one and all. Respected dignitaries, myself Arun Sornapudi. I've been working in Goa Shipyard Limited for the past 10 years. I've been working in the position of manager in the Department General Engineering Service. Our department deals with diverse products, including inland vessels and other pleasure crafts for waterfront tourism. I'm going to detail about these products in the coming slides. This is our CAD infrastructure. And as you can see, we are modernizing CAD. Still, a lot of construction is ongoing at the moment. We can construct vessels up to 135 meter long and 23 meter wide. And we can undertake vessels and the size of OPV at a time 14 numbers at various stages. As you can see, we are having a ship lift facility which can dock and undock vessels up to 135 meters long. This is our growth pattern. We have started as a barge repair facility in 1960s, and we started constructing barges, other auxiliary vessels, medium auxiliary vessels, warships. And as of now, we are constructing offshore petrol vessels, fast petrol vessels for Indian Navy, Indian Coast Guard. And at the moment, we are constructing frigates for Indian Navy. This is our main areas of operation: shipbuilding, new construction, ship repairs, and general engineering service. Shipbuilding. This is the conventional shipbuilding section, which deals with construction of bigger vessels like these offshore petrol vessels, fast petrol vessels, sail training ships, and other vessels. And ship repairs, which undertake ship repair jobs on contract basis. We have repaired around 100 vessels in the past decade, and we can undertake repairs up to 5,500 tons and length not exceeding 135 meter and beam not exceeding 23 meters. General engineering service. This is the diversified group for which I also belong, which we deal with all land-based simulators, barges, and CPP propulsion with tie-up with Wärtsilä. And we undertake construction of diversified vessels like tugs, fishing vessels, passenger ferries, and other boats. And for the boats part, we have constructed, and we are also at the moment constructing different patrol vessels, tourism boats, interceptor boats, survey boats, rigs, and passenger ferries for eco-tourism. And as at the moment, we are constructing 12 number patrol boats to Indian Army also. These are some of the salient features of the patrol boats, which we have constructed to various customers in the previous decade. So I'm going to highlight the salient features of these boats. These are 12-ton interceptor boats which we have constructed for Ministry of Home Affairs. We have constructed 64 of them and we have delivered them in the year 2008 to 2010, and most of the boats are still under operational. This displacement is around 12 ton, and it can achieve a maximum speed of 35 knots. And these are powered by twin inboard 500 bhp engines. And these are the fighter interceptor boats, which we have again delivered to Ministry of Home Affairs. And these can achieve speed up to 40 knots. And these are propelled by twin OBM, which powered each 270 bhp. These are fast interceptor boats, which we have given to Mauritius Coast Guard. We have delivered 11 number FIBs in the year 2015. These can achieve a maximum speed of 35 knots. These are powered by 500 bhp engines coupled to twin water jets. And these are the 30 knots patrol boats, which we have given to Captain of Ports, Government of Goa. And this can achieve 30 knots speed, and this is powered by conventional propulsion. And this is again a 30 knots patrol boat of the same variety which we have described earlier. But the propulsion for this particular boat, we have installed stand drive as per the owner's requirement. And as you can see, all these are the same three variants. But only thing, one is propelled by water jet, the other by conventional propulsion. This one is propelled by stand drive propulsion. This itself showcases the amount of design modifications Goa Shipyard is open to depending upon the customer's requirement. And these are the survey motor boats, which is again propelled by stern drive, which we have constructed for Indian Navy. The main purpose of these boats is for the survey operations. That is the reason why the speed is not the priority for this thing, whereas the stability is the main issue. And the hull was designed and constructed to the utmost satisfaction of Indian Navy. And these are the fast ribs, which can achieve a speed of 32 knots, which was generally placed on board a motherships. These we have delivered for Indian Navy. This is again a 6.5 meter rib, which we have delivered for Indian Navy. These are the 8.5 meter tourism boats, which we have constructed for Government of Goa. The best thing about these boats are these are very compact, lightweight boats, which could be carried on board a trailer to anywhere within the state. And the cost is also so low that anyone can afford these boats. And not even the government bodies, but also the private parties who are into short-term, short-distance tourism can afford these boats. And these are the again a different variant of 5.5 meter tourism boat, which is again a very cost-effective boat, which we have constructed for Government of Maharashtra. This is compact, lightweight, and very cost-effective. And our main area of interest is the catamaran passenger ferry, which we have recently constructed for Government of Uttar Pradesh and state body QPRNN. Just 20 meters, the beam is around 8 meters, and breadth of each hull is 2.4 meters. And it can seat up to a maximum of 80 passengers on 20 tables, 11 on lower deck and 9 on upper deck. The lower deck is completely air conditioned, and it houses audio and visual arrangements, which documents the importance of the area. This ferry shall be flying in Varanasi. So a nice documentary was made on the importance of these guards and the Varanasi as a historic site itself, and it shall be explained to the guest while it is being plied down from one guard to other guard. The maximum speed it can achieve is 8 knots, and the propulsion we have installed twin inboard engines driving fixed pitch propulsion through gearbox. These are the salient features of the ferry. It has a completely air conditioning deck, which can house more than 50% of the passengers. And as you can see, it has a catamaran hull, so it has twin engine rooms and a small pantry on the lower deck for refreshments. This is a small aesthetic video which we have developed for the owner for taking his viewpoints on interior designs. And as you can see, this is not the final version which we have delivered, but these are the customization which we can give an option to various state governments depending upon their own taste. As you can see, the interior walls, they could be painted depicting the importance of that region, and other arrangements like seating and everything. We could customize everything depending upon the owner's requirement. These are the main equipment which we have fitted in this ferry. As you can see, all these equipment, make and models, you can see Volvo Penta engine, ZF gearbox. These are nothing sort of an state-of-art OEMs which we have installed for these passenger ferries. So that during the life of the ferry, there should not be any operational failure. And this is the finished ferry which is in operation. This video was taken during our trials at Goa. As you can see, it is an excellent ferry with a good stability point of view and maneuvering point of view also. It has passed all the tests as per the requirements of owner and class. Passenger ferry business of interest. We have already constructed the shown passenger ferry to EPRNL. But we are doing a little bit more than that at the moment, and we are modifying the design to suit more eco-friendly propulsion with higher efficiency. As everyone here knows that electric propulsion has a more promising future in the shipbuilding industry while compared to other propulsion systems. It not only improves the overall efficiency of the ferry, but also reduces the global carbon footprints. The following are the main alternate propulsion arrangement which is being considered by GSL to make the ferry more eco-friendly. One is pure battery ferry. The other one is a battery ferry with solar panel, which are installed on the superstructure part. And these solar panels will keep on charging the batteries while in operation also. And the modified ferry with electric propulsion shall be offered to various customers for river navigation and tourism purpose. Being Goa Shipyard Limited within Goa, we have a huge domestic tourism, and there are many rivers like Juvari and other rivers wherein the flying of customers from one point to other point is normally through ferries. So we will be in touch with the state government of Goa for progress of these ferries. And other business of interest is Andaman Nicobar Islands for inter-inland tourism, government of Kerala for use in blackwater tourism, and UP government for commuting of people over Ganga River and other historic sites. Though one ferry is already in operation, any future requirement is there. We would like to propose a more eco-friendly solution to UP government and various other governments like government of Telangana, Andhra Pradesh, Karnataka, or Maharashtra, and all other governments within India who is having good inland water to infrastructure and requirement for domestic tourism. These are the main challenges which are being faced by waterfront tourism. Though India as a subcontinent has a huge coastal area and numerous rivers with huge potential for inland navigation and water tourism, most of the water bodies are very underutilized. And as a center for all stakeholders, we would like to request that major private and public entrepreneurs should come forward for establishment of marinas and floating docks for promoting inland tourism and navigation. State tourism department should concentrate more on infrastructure development for inland tourism. Developing inland tourism shall propel other ancillary industries which will drive the marine economy. Waterfront tourism, GSL's future plan. GSL had a very diversified product profile when it comes to small crafts, ancillary vessels, and passenger ferries, as we have already shown. And GSL is in talks with various governmental bodies for supply of GRP products like passenger ferries, patrol boats, ambulance boats, water taxis, and other GRP products, and maybe steel or aluminum products, which could enhance the inland tourism. GSL is also tapping inland in addition to domestic market, with a potential foreign market for supply of these inland vessels such as GRP patrol boats, tourism boats, and ferries. GSL has already exported 11 number fast interceptor boats to Mauritius and looking forward for other potential markets wherein we can supply these ancillary products. I sincerely thank Dosters for giving Goa Shipyard Limited the opportunity to share our viewpoints on inland tourism and waterfront tourism. And I sincerely hope that there will be a substantial development in the coming decade as far as the use of river bodies for promoting inland tourism. And I thank all the dignitaries on behalf of Goa Shipyard Limited. Have a good day. Thank you.
Thank you, Mr. Sornapudi. Now we have the third session by Commander K.M. Zakaria on barge design for transporting ammonia by river. Commander K.M. Zakaria, retired officer from Indian Navy and holds a B.Tech 4th batch from the Department of Ship Technology, CUSAT. He served in the Indian Navy from 1983 to 2006 in various capacities, currently running a ship design office, ZAC Consultancy in Cochin. Now I'd like to invite Commander K.M. Zakaria to start off the third session.
Good day to all the listeners of this presentation. I'll be presenting a real-life case of how a dry cargo inland barge was converted to an inland liquefied ammonia gas carrier. Fertilizers and Chemicals Travancore, FACT, has a large demand for ammonia for their processes. This is one of the leading fertilizer manufacturers of the country, as most of you know. They need ammonia for several of their processes. The requirement of ammonia cannot be met by their in-house production alone. So much of this requirement is met by purchasing ammonia in liquid form from outside firms across the country and abroad. The liquefied ammonia used to reach their facility either by rail or road and also by waterways. Very limited amount of ammonia, liquefied ammonia, was supplied by road by bullet tanks mounted on trailers. About a decade and a half ago, a large part of their liquid ammonia gas requirement was met through waterways. There used to be a couple of custom-built ammonia barges. Additional requirement of liquefied ammonia gas was met through FACT's own railway wagon carrying bullet-shaped ammonia tanks mounted on railway wagons. Transportation of liquid ammonia gas through waterways proved to be very costly in those times, as the contract for supply was held by a single firm who owned the barges and there was no competition. This arrangement stopped as this barge got entangled in several legal cases and the barges were impounded following some court order. Thereafter, the ammonia requirement was met by railway and road route alone. Over a period, the FACT owned railway wagons completed their life and had to be decommissioned. Though the railway wagons became unserviceable, the tanks, the bullet tanks as they were called, were still serviceable and they were now available for use. With both waterway and rail route of ammonia supply stopped, the only route to get ammonia was through roadways. It was, however, found to be very risky to transport ammonia, liquefied ammonia by road due to the heavy traffic in the route. And there were a couple of serious road accidents involving ammonia gas carriers. And therefore, FACT wanted to now get most of their ammonia through waterways. Let us also see what are the advantages of waterway for supply of liquid ammonia gas. As far as FSCT is concerned, they have good connectivity through the waterways, connecting their units at Ambalamedu, Ambalamugal and Cochin port. Normally, a large barge can carry very large number of ammonia bullet tanks, and obviously that many number of ammonia trucks will be taken off the road, and transportation of ammonia through waterways, if correctly accounted, will be much cheaper than all the other means. The safety of water transport need no extra mention, because the other routes, through the road, was fraught with risk. Now, FSCT had their bullet tanks available because the railway wagons were unserviceable now. So making use of those available bullet tanks was a good economic option. So when this requirement came up, there was no barge readily available. So FSCT looked for an existing barge, if that could be converted to become a ammonia carrier. So it is at that time a cargo barge which used to carry dry cargo for inland service was available. This barge was designed to ply through the Champakara Canal. The Champakara Canal is a canal which leads to the FSCT units, and also connecting to the port trust of Kochi, and also to the FSCT unit at Ambalamugal. So the barge was available, and the routes were also, this barge could ply through that route. So a combination of such factors, that the demand for liquefied ammonia gas and availability of unused bullet tanks and availability of a barge, prompted FSCT and a barge owner to explore the feasibility of converting that barge into an ammonia carrier. The main particulars of the barge, which is now available, is as shown. This barge had a cargo carrying capacity of 650 tons when it was used as a dry cargo barge. What I am showing now is a general arrangement of the dry cargo barge which is available. It is just like any other inland barge. It had a single hold, as you can see in the picture. It had double bottom tanks and wing tanks also. Now, in this picture I am showing how the bullet tanks were mounted on the railway wagons earlier. Now, as I told earlier, these wagons are no more available, but the bullet tanks are available. See, in this picture, you can see the feature of these tanks are like this. These tanks have an inbuilt foundation, this green colored structure, which is welded onto the tank, and the whole tank is now kept onto the foundation on the wagons. This is how it used to be carried on the railway wagons. Now we have to see if these tanks can be mounted on similar foundations on the barge. The dimension of the typical bullet tank is as shown. It is about 16.5 meter long and had a diameter of almost 2.5 meters. When liquefied ammonia gas is carried in this, it could carry only about 32 tons of ammonia gas, liquefied gas, in this tank. The tare weight of the bullet alone is about 26 tons. So together, a fully loaded tank would weigh close to 60 tons. So we carried out a feasibility study and found that six such bullets could be kept on this barge. So you can see here how we plan to keep those bullets. It's almost filling the entire hold. You can see 3 tanks across and lengthwise 2 tanks. We couldn't have kept additional tanks on top because in this route along the Champakara Canal, there are several bridges. So the air draft is limited. So we couldn't have added more tanks. Also, the visibility from the wheelhouse also would have got affected. There were several technical challenges that we had to face in this conversion. Since these bullet tanks were carrying dangerous cargo, additional structural modification on these tanks could not be done. If any structural modification to the foundation or etc. was done, we have to again submit these tanks for reclassification by the societies. So it was decided to use the same inbuilt foundation of the tank, but make suitable foundation arrangement on the barge to receive these bullets. So designing fresh foundations for such huge tanks was one of the biggest challenges we faced. So I am again highlighting the foundation arrangement. We would retain the inbuilt foundation of the tanks. This type of long structure is on either side of the tank. And we'll have to make suitable arrangement on the barge to support these tanks. Another challenge we faced was the tight fit space available in the cargo hold. When we kept this 3 tanks across the hold, there was hardly any space between them. So to install huge structures, ready-made tanks in this space was also a problem. And fixing them with limited space to access the foundation also was a big challenge. With 3 tanks across the hold, the space between any 2 tanks is as low as 188 millimeters. In this sketch, you can see the arrangement of 3 tanks across the barge. And as I said earlier, the space between these 2 tanks and the side of the hold is only 188 millimeter. In this picture, you can see the typical cross-section of the barge. It had wing tanks and double bottom, and this is the hold space. There is no hatch cover for this barge. Yet another challenge we had was the curved shape of the hold in the forward region of the barge. I will explain that in a sketch here. This barge design was such that the front end had a curved space. So that limited longitudinal adjustments of the position of the bullet tanks in the barge. This was important to maintain the trim of the barge when loaded, but we couldn't take these bullets forward any further because there was no space. Of course, towards the rear we had, but a real balancing act was required to get the suitable trim. Now, the next challenge was to design the foundation for these tanks. We had to design foundations afresh. That foundation had to match with the foundation structure on the bullet, as well as the main structure inside the barge, the floors in the double bottom, and the longitudinal girders, etc. While designing the foundation, we had to take into consideration the heave, pitch, roll of this bullet loads, the sloshing force of the liquid in the tank also had to be considered. Of course, for calculating these figures, there are rules available in the classification rules. In this section, I am explaining how we made the foundation for this tank. In line with the floor of the double bottom, we erected transverse beams as shown, the green colored thing. They would take the point load from the bullet tanks and distribute onto the floors. And in lengthwise, each of these floors would have a pair of longitudinal structures as shown in this perspective view. The pink colored structure would match with the inbuilt foundation of the tanks. In this picture, I am only showing the pair of longitudinal foundation in one end of the bullet tank. Similarly, one pair will be in the aft end also. So from these structures, the load will be transferred onto the transverse beam structure, which in turn would transfer the load to the floors at the bottom. The dimension of the tank and the existing longitudinal girders would not match. So that is why we had to give this transverse girders to distribute the load. The ship's longitudinals had its own spacing, which was not matching with the foundation of the tanks. So this was a real challenge to design a foundation to suit all these requirements. Here I am showing a perspective view of the hold space structure of the barge. Only the hold is shown. I have removed in this picture, I have removed the deck plating. You can see the existing longitudinal girders in the double bottom and the transverse floors. So this pair of structures which support the bullet is shown here, and the load will be transferred to the transverse beam, which is lined with the floor of the tank. As per the rule of the design of such tanks, we had to provide a pair of saddle supports which has to cover a particular circumference all along the circumference of the tank. This is a rule. So we had to give saddle supports also. This green colored one, I will show some more details in the next slides. So this is a one, I have only in this picture shown only one bullet kept here. Similarly, totally there will be 6 bullets in this whole space. This is a little more close-up view. This pink colored is the existing structure on the bullet. That has to be matched with the longitudinal foundations which we were to design. This is the details of the saddle structure which we had to design. The saddle structure also will support the existing bullets. The bullets had their own insulation also around, as you can see. So this is how we designed the saddle support. Since this tanks were carrying liquid ammonia at -33, we didn't want that low temperature to affect the structure. So we had given teak wood insulation between the surface of the tank and the foundation structure. So here is some photographs of the barge while under conversion. You can see these were the beams which would transfer the load from the tanks to the floors below. These are the longitudinal foundations which would take the load from the existing foundation on the bullets and transfer to the beams. This is the saddle structure under construction. We also had few administrative challenges to face. This barge we are talking about was built in 2007. At that time, there was a provision to build barges under IRS certification. It is not a full class approval, but it should be known as a IRS certification. This system doesn't exist now. The barge was, however, built as per the IRS rule, it didn't meet all their stringent requirement at that time. So since it was now going to carry dangerous cargo, we had to get it classified. Due to several reasons, the owner of the barge decided to get it classified under the Italian Classification Society, RINA. Since the design was already done as per IRS rules, RINA didn't have much difficulty in examining the total set of drawings and take it under their class. And they gave an approval as liquefied ammonia gas bullet carrier for inland waterways. Another challenge we faced was that for this dangerous cargo for inland waterways, there was no rule available at that time. But RINA provided us with the European rule for carriage of dangerous goods for inland waterways, which was a good start, and that was acceptable. Here I am showing pictures of how these bullet tanks were loaded into the barge. These are some of the pictures of loading of bullet tanks to the barge. The foundation structure is, you can see, is ready now. The foundation and the saddle structure are ready. The tanks had their insulation, but for loading purpose, the insulation had to be removed, which would be done in situ after the tanks were put in the location. So here you can see 2 tanks are installed. And this is one of the final pictures where all the 6 tanks have been installed into the whole space. There is now no space extra. It's quite a tight fit installation. After the conversion, a full inclining experiment had to be done because it was a major modification for the barge. And through this inclining experiment, we could establish the final light ship weight and the position of the CG of the ship. Several safety features also had to be incorporated. Now, this safety features were as dictated by FACT. So they were monitoring all those requirements. From the barge side, we installed what is called water curtains all around the barge, covering all the bullet tanks. Because if there is a leakage of ammonia gas, the first action is to spray water all around it and dilute it. These tanks are not under pressure. They are at low temperature, and it is not a pressurized tank. This is the picture of the completed work. You can see the 6 number bullet tanks now loaded into this barge. This is the final picture of the conversion project. This is the barge fully ready for operation. And this barge is supplying ammonia gas to FACT from 2013 onwards, regularly supplying. It also transports ammonia from a FOCT unit in Elur to their other unit at Ampalamede. So this is all about this conversion project. And that ends my presentation. Thank you very much.
Thank you, Commander. Now we have the 4th session by Professor Ananda Subramanian on pleasure yacht design. Professor Ananda Subramanian is a retired naval architect and presently consultant at the Department of Ocean Engineering, IIT Madras. His professional experience is 38 years of teaching and research at IIT Madras and consultant to the ship design, shipbuilding, and research and development institutions globally. His major area of specialization is naval architecture and ocean fluid dynamics application related to ships, propulsion, ship stabilization, design of pleasure crafts using advanced vacuum infusion, sandwich construction. I'd like to invite Professor Ananda Subramanian to start off the 4th session.
Good morning, everybody. Thank you for the privilege, the honor of inviting me to give a presentation on the design experience of our own concept of what we call the island day cruiser, and in the process to highlight the challenges of logistics and infrastructure build, which is also the theme of this one-day conference, DIMS-Lite webinar on pressure crafts. Let me introduce myself. I am Ananda Subramanian, retired from IIT Madras as professor, where I worked for almost 40 years. And I have the privilege of being the first student of the first batch of the Department of Ship Technology, University of Cochin. The structure of my presentation is as follows. I straight away get into the core of this topic, that is a brief description of the location-specific potential for tourism, which are actually plenty in our own state of Kerala. I get into the design elements of the island day cruiser, and then into the brief hydrodynamics of power assessment through model testing, the structural design for which we have used the new concept of vacuum infusion of resin using sandwich hook, which I believe is for the first time on a boat of this scale in this country. In the process, we unravel the constructional and logistical challenges of building such a vessel, and we are happy to look forward to the fact that this could be a path-breaking effort towards promoting tourism in the state and as well as in the larger geographical boundaries of this country. And I sum up with a conclusion. Now, not far from the Cochin airport and Cochin city, we have the island called the Padampalli Thuruthu, which is actually a tiny island in the middle of the river Periyar, about 5 kilometers before it joins the Arabian Sea at Cherai. The place is well known for the heritage of the Muziris, and it is home to historic temples and Jewish settlements and synagogue, and therefore the region is a fast-growing tourism destination. It's just about 25 kilometers from Cochin airport, and this map shows you where the island is, and within that island we have the island dream home. Now, these are some of the typical panoramic views that you get of the river. And here we have the island dream home with a jetty which is just waiting to receive the boat, which is already here in Cochin, going through the process of commissioning under the class and Kerala Inland Vessel Authority regulations. The environment for this place can simply be described as silent, serene, soothing, and timeless, a perfect getaway for a holiday. And if you couple it with the fact that there could be an imminent rain with thick clouds, that could add to the charm of the place. And there is a spot to stay by the riverside. Let me get to the concept of the hull form. We wanted a classic form which is characterized by a wide beam, a rounded transom, tumble home, and a gentle speed of 8 knots, which technically would translate into a crude number of about more than 0.35. The broad dimensions of the vessel are 12 meters length, 3.5 meters beam, and the draft was carefully designed to be well controlled, not to exceed 0.7 meter. And finally, we have been able to achieve a full load draft of 0.65 meter with a displacement of 7 tons. It is important to emphasize that the challenges of design of a small craft is much more than designing a big ship, because the scope for error is very narrow, and unless one has good control on the weights, it becomes sometimes very difficult to handle towards the end. We started with the tank tests, which are characteristic for any vessel, and the purpose of the tank test is to ensure that the flow is good, the flow to the propeller is good, the powering characteristics are good, and therefore you match with the correct engine power, not to overload it or to underpower it. Now, without getting into the nitty-gritties of towing tank tests, which all of you must be well familiar with, here are the curves which show that for the design speed of 8 knots, the resistance and the effective power are only at the gentle rise of the curve of resistance, and therefore in that sense, the hull form is optimal. You can see the hull form here, which is characterized by a gentle dead rise, and there is a good inflow to the propeller. There is a vertical rake stem, which later, out of the results of the tank test, we improved to have a better angle of rake. Any model has to be tested, and we have to make a model to precision, and this is a classic example of how the plug is made for the eventual manufacture of the die and final product in the form of a model on the scale 5:1. This video shows a typical tank test. You can see the flow at the stem because of the vertical rake, the water was rising up, and this gave us a good insight that we could modify the shape of the stem with a more inclined angle. Otherwise, the performance of the hull is very good. The waves are subdued. This is inside of the plug which was manufactured in the towing tank building at IIT Madras. That is the full form. And this is a very long time consuming process. And the quality of finish of the plug is going to dictate the final quality of the die and therefore the final quality of the product, which we can make in repeat numbers later. To talk of some of the salient aspects of the structural design, the hull is of sandwich construction, which means the core material is divinyl closed foam PVC, and on either side, this is bonded with quadriaxial fiber of at least 2 layers on either side. The outer will of course have the gel coat and the conventional chop strand mat. The advantages of this are noteworthy because we use the so-called process of vacuum infusion and sandwich core construction. It means less resin is used. The hull has higher flexural strength. There's considerable weight saving. The molding process is rapid, and the hull provides that much more reserve buoyancy. This is just a typical section of the hull where you appreciate the dead rise of the floor, and more importantly, the hull was designed to be of low height so that the boat can negotiate under bridges where the air draft is quite restricted. This is the plan form which shows the main members, the longitudinals and the transverses. And the transverses here are spaced at 1.5 meters apart. Now, the dimensions are given here as to what we finally evolved. The main consideration was, although the powering was quite adequate, we decided to go for enhanced breadth. Therefore, the breadth was changed from 3.08 meters to 3.5 meters, and the draft was easily controlled to be within 0.65 meters. The resistance test results you can see at 8 knots, the ship resistance is 2.15 kilonewtons, resulting in an effective power of 12 horsepower, which would translate into an installed power of about below 25 horsepower. We finally decided to go for an engine of 38 horsepower, a Mitsubishi engine, which would develop the full power at 3000 RPM, and therefore the design speed performance of the engine is about 2200 RPM, fitted with a 2.5:1 gearbox. Now, this was a huge effort and this was a great teamwork. I'm proud to say that with my team of about 30-40 staff, many of them are research scholars, project officers, technicians, electronics, they were all fully passionately involved in the manufacture of the die. which of course started from the plugged and then the negative form. The constraints of space and the constraint of the shutter width forced us to rethink on the die to be 5 parts instead of, let's say, maximum 2 parts. So here you are seeing the die in several pieces, and you can see the assembled die with the superstructure plug also being manufactured. And you can see a number of my group involved passionately in the work. So here, after this, we had hired a place at Gindi near IIT Madras, where we shifted the entire die, assembled it again carefully, which is another time-consuming process. And in order to facilitate the vacuum infusion, it is so important that you cannot have the tiniest of leak within this die. And therefore, we were preparing for the lamination. This was a very demanding job. The right side picture shows the models, hundreds of which we have tested for industry, not only in India and abroad. And I must say with humility that we have the satisfaction that we have a number of clients all over the world who are happy with the kind of work we have been doing. Now I come directly to the challenges of the vacuum infusion. You can see a maze of tubes, peel plies, spiral tubes, inlet outlet points, and the final preparatory level which you see in the right side picture, which is then ready for vacuum infusion. Essentially, and this is a picture after the vacuum infusion has taken place, you can see the wet look of the surface. Now, the imperative conditions for successful vacuum infusion is the vacuum has to be maintained at absolute zero, as you can see the dial showing that, and that sustained vacuum should be retained for at least 4 to 5 hours, giving enough time for the slow setting resin to penetrate the layers, the sandwich core material, and to set over a period of 1.5 to 2 hours. You can also see that resin is mixed by the barrels. That actually we mixed about 400 kilograms of resin, something unthinkable in the manual molding process. This also means that the entire hull is molded in a matter of just about an hour, and the setting time is just another 2-3 hours after that. On the right side lower, you see the catch pot, which is an essential ingredient for successful vacuum infusion to take place. And on the upper figure, you see the preparatory work going on. It was a wonderful experience, and it was a great satisfaction that we could make an excellent hull form using this process, which I believe was done for the first time on a hull of this form and size in the country. So on the left side, you see the hull is ready now and we are fitting the bulkheads. On the right side, we are doing the similar process for the deck house molding. This is how the hull shapes up, and now inside it is the ship ready, and we have to now pry open the die, which was a challenging task because you can see it is sitting at the bottom and we have to virtually take the rug off the feet while we try to remove the die and finally have the ship. Some of the technicalities, the tensile strength properties compared between hand layup and infusion. You can see in the tensile test that the tensile strength improves from 234 for hand layup to 287. And the Young's modulus increases from 12.29 kilonewton per millimeter square to 16.16. So there is more than 25% improvement in the strength characteristics in the tensile test. Similarly, in the flexural stress, you can see that the flexural strength has gone up from 320 in hand layup to 370 for the infusion process. Similarly, the flexural modulus also goes from 6.65 to 10.93 kilonewton per millimeter square. Not only that, there is a tremendous amount of weight saving, uniform homogeneous strength. So all these make the vacuum infusion process a very desirable process and an improvement from the conventional hand layup. Resin saving is a very important key factor, which means your hull is going to be much more lightweight. So without going into all the details that happen in between, I am now coming to the final hull form. You can see, I would say that there is a gracious hull form that is resulted from our process. And the island day cruiser, as we call it, we gave it the name Oru Premaganam. It's a classic motor yacht built for comfort for cruisers. It can easily take 10 to 12 people or even more, but we wanted them in friendly, comfortable environment. So we restricted the numbers to maximum 12. It has a bedroom, it's a lounge, it's a kitchenette, an environment-friendly bio-toilet, very important, and a cruising speed of 8 knots for river and backwater cruises. Now, what I have presented so far highlights the logistics of design and fabrication using the advanced technology of vacuum infusion for superior performance and creating a new market avenue for tourism. We had our challenges when we built this hull in Madras or Chennai, that we had just about space to keep the boat and build the boat. And it was quite a challenge to take it out of that building and then transport it to Cochin. So here you can see the constraints of the space that we had. You will also appreciate the beautiful classic rounded transom and the tumble home of the hull, as you can see in the aft region. Now, a little bit of the description of the interior. From the main deck at the aft, you step down into the lounge. And on the right side, you see a comfortable bio toilet, which means the waste is biologically degraded and rendered into innocuous grey water. You see the main engine here, engine room, and you see the lounge. And as a first attempt, we are quite pleased that we have got a fairly satisfying looks, and we need to do much more as the vessel heads for its home destination of this island dream home, Padampalli. You can see the constraint with which the boat was taken out on the left side. On the right side, you are seeing the diesel generator set within the engine room, 5 kVA capacity. We have a sun deck at the aft, which of course will have a canopy because otherwise you cannot enjoy the harsh sunshine that we will have there on a bright sunny day. The final challenge was the transportation, and this is oversized cargo to go by road on a trailer because of the 3.5 meters beam. And it's a tribute to the driver, a single driver come owner, who without anybody accompanying him did the entire 700 kilometers on this long trailer truck. And it was taking almost impossible looking turns. And this is just at the exit from our factory taken into the Mount Road, a sharp turn. So back in Cochin, with the help of Bristol boats and our good friends at Samudra Shipyard, it was a cakewalk using 2 simple cranes married together, lifting it and putting it into the waters in Arur. So finally, the most exhilarating moment when the ship finally touched water, and we were pleasantly surprised and happy that it was maintaining the intended draft. The trim was perfect, the balance was perfect, there was symmetry. So we have built the awning at the aft, and these are some of the latest pictures taken at Arur. So in conclusion, we have presented a new design with a new technology going into the details, and we will be happy to share this with whoever wants to have these data. And we have now got a new technology and design offering new potential and rejuvenation of pleasure tourism in the state and in India. There would be creation of new economic opportunities. Thank you.
Thank you, Professor. Now, I'd like to invite Mr. V.J. Matthew, who's the chairman of Kerala Maritime Board, to start off the 5th session on the development of smaller ports in Kerala.
We are blessed with a vast coastline of 590 kilometers, with 17 minor ports, long inland waterways, 44 rivers, and 33 dams. I'm sure that when these ports are developed to meet international standards in all aspects, Kerala will spearhead the economic growth of the country. The sole mission of the Kerala Maritime Board is to be the facilitator of such a change in Kerala ports. To begin with, Kerala Maritime Board aims to develop ports of Viഴിഞ്ഞം, Adikal, Bepur and Kollam out of 17 minor ports. Plus one minor port is though notified. It is Port of Kottayam. It is on a PPP basis. On the first phase, after developing Adikal, Bepur and Kollam and Viljam, we'll be developing other minor ports, considering the cargo movements. We're also planning to invite investors for more and more coastal road movements and passenger vessels connecting ports of Kerala and other Indian coastal states, and even to connect Maldives. Inland waterways connecting north to south of Kerala will be commissioned in 2021. There is a dream project of Honorable Chief Minister. The Kerala Maritime Board aims on investors mainly on PPP basis in the Kerala ports as well as in the inland water minor port in Kottayam. Initially, we want to make our all ports clean, complying ISPS code, a sufficient draft and headed by true professionals. Board also intends to develop Adikal port in the first digital automated port, cargo handling port. We start with dredging, make available working port trucks, sufficient cranes, repair facility and maintenance workshop. Bepur is also having all these infrastructures. We aim to upgrade all the ports to the international standards. And we have identified areas where free flow of water into the sea are blocked due to piling up of sand, due to flood and other reasons in the dredging. And we will be doing dredging in all the ports. And instructions have been given to commence dredging in Adikal within the second week of February. And the capital dredging is happening in Bepur. And the steps are being taken to clean the inland waters like the river Ganga and Varanasi were cleaned. Regarding coastal cargo movement, as proposed by the Kerala Maritime Board, the government has published an incentive scheme for vessel operators, and the benefits of the same will be passed on to the trade. As of now, the coastal transport is not happening in the state of Kerala because no operator is coming forward, even after giving substantial incentive. Because of that, the Kerala Maritime Board has decided to charter vessels of its own or on joint venture basis. And on getting permission from the government of Kerala, we will be starting soon the coastal cargo movement from Cochin to Bepur, Adikal, and also from Cochin to Kollam and Viljam connecting to Tuticorin. We are also planning to move the liquid cargo, petroleum products, using barges and LPG gas and Ro-Ro vessel in the coast of Kerala and Mangalore. We are also the licensing authority for KIB rules, Kerala Inland Vessel Rules, wherein we give license to all the inland vessels, houseboats, rafts. The KIB rules is under amendment, and we have also decided to install bar-coded hologram number plates in all the vessels, houseboats, to ensure that it is not being misused. We have already discussed with petroleum companies for the movement of petroleum products using coastal and inland waters. Even LPG can be transported from Mangalore, Jaipur, Adikal, and Kollam in barges and Ro-Ro vessels. Reduce congestion in the road. The board has already decided to computerize our ports in Kerala and all the operations of the port and even offices, ensuring 100% transparency. We are also for construction of dry dock, small and medium type vessels, ship repairing yachts. And we had also conducted a few discussions with the Cochin Shipyard for their assistance. We have sufficient land in ports right from Kasaragod, Kannur, Adikal, Jaipur, and even Kollam, Vinyam, and Alakki. The Maritime Board are also interested to invest in port and tourism, and we welcome those investors to Kerala Post and Ports and can come with any proposal to Kerala Maritime Board. There won't be any hurdles, no delay, and it would be 100% transparent, and you can do easy business with Kerala Maritime Board. During the COVID pandemic, we started the crew change in Vinyam. At that time, Cochin was doing substantially well. And even before the COVID, the board has decided to declare the port of Vinyam, Kollam, Jaipur, and Adikal as international crew change, bunkering, and other incidental services terminal. And we started the first vessel Evergreen group at Vinyam for crew change in July 2020. And as on 31st January 2021, Kerala Maritime Board would succeed in bringing 139 vessels for crew change and other services like ship management change, survey, bunkering. And in the month of February, we already have confirmation for 40 vessels. So by the end of or in March, we will be able to attain double century of 200 vessels. That should be the history in Kerala as well as in India. A minor port is bringing 200 vessels for crew change and other incidental services. For doing the coastal transport, as I mentioned earlier, we are planning to charter vessels, and those investors in the shipping trade who are hearing me can approach Kerala Maritime Board Chief Executive Officer and give you a proposal to invest in Kerala. And we assure you that there won't be any issues, no hurdle. There won't be, it will be 100% transparent. And Honorable Chief Minister and Minister of Ports are giving full support to the Maritime Board. And with the support, we have decided to acquire 500 acres of land in Adikal Port to start various port-related activities and other warehouses, etc. Private investors have come forward to invest in Vinyam, Colombo passenger ferry vessels. And we have already discussed with the Lakshadweep authorities to start Mini-Koi Kollam passenger cum cargo vessel. Similarly, from Kavaratti side to Vinyam, Adikal. Jaipur is already doing good business with Lakshadweep, and that will continue. Even though there was some news that the cargo or the vessels calling at Jaipur are being shifted to Mangalore. That will continue. We have already confirmed with the Lakshadweep authorities. And we are also planning to bring vessels for crew change as well as for other incidental services, bunkering, etc. to Kollam, Jaipur, and Adikal. Recently, Maritime Board decided to start a tourism division for Kerala Maritime Board. That is called Maritime, Marina and Cruise. And soon we'll be concentrating in the tourism sector also. We also welcome investors for the cargo movement, ro-ro vessels, and passenger come high-speed crafts connecting Trivandrum to Calicut or Kannur. We also propose to develop beaches in Kerala to international standards on a joint venture basis. So private beaches as well as public beaches like we see in foreign countries. So those investors who are interested in all these fields can approach our new Chief Executive Officer, Sri T.P. Salient Kumar IRS, who's a deputation and joined Maritime Board recently. As I mentioned earlier, we are planning to install barcode number plates with hologram in all the houseboats, all the crafts registered under the KIB. And we also propose to give free insurance to the crews and the employees of the houseboats and other crafts. We are also serious on waste management. And we are also interested to proceed with amusement park along the coastal side. And soon we'll be holding a trade meet in Kannur, Calicut and Kollam. And already we got good offer that we'll be getting monthly 400 containers, say from Adikal Kannur side, particularly coffee from Cook. And those investors, don't worry on the return cargo. We are giving substantial incentives. And after the mega meet, investors meet, we are sure that our coastal movement in Kerala, we can take it to the heights. And we welcome all the investors in the shipping sectors, the tourism, adventure sports, high-speed boats. And we confirm once again that it will be a hassle-free business with Maritime Board. And there won't be any hidden cost. Thank you, and I wish this motor show all the very best from Maritime Board. Thank you.
Thank you, sir. Now we'll start off the sixth session with Mr. Sandip T, CEO of Navagati, on the water taxis. Mr. Sandip T, who's the CEO of Navagati, Navalt Solar and Electric Boats, which is the only firm in India with experience of building large solar passenger ferries. Apart from pure solar with no fuel on board for applications that needs higher speed, longer range or heavier cargo, Navalt is developing hybrid solutions. The first air-conditioned double-deck electric ferry of 100 passenger capacity, fastest solar boat with 12 knots speed, and solar-propelled fishing boats are some landmark projects that Navalt will launch soon. He's also the CEO of X-Ship Design and Analytics. He's CEO of Navagati Marine Design and Constructions. Navagati Marine Design and Construction is one of the leading boat manufacturer and design consultancy in the country with experienced design and construction of innovative watercrafts. I'd like to invite Mr. Sandip T to start off the session.
Greetings to all. I am Sandip, CEO of Navagati Group, that includes Navalt Solar Boats. Today I am going to talk about sustainable marine transport. I will cover the whole philosophy and application. Towards the end, I will also talk about one of our recent product launch, water taxis. Ships and boats are built for a purpose. Before we understand the point of the vessel, an essential starting point, we need to answer the question, why do we need sustainable boats or solar boats? Now there are multiple reasons for it. They can be grouped as environmental, comfort, safety, low Opex, low cost, that's TCO. The most apparent context when we hear sustainability is climate change and the positive impact it creates to reduce greenhouse emission. It is essential to understand the scale of impact when we discuss any solution. If you see the total greenhouse gas emission, this is from a WI report of 2016, the transportation contributes to 15.9%. Of this, shipping, both inland and seagoing, contributes 1.7% of total. It's a huge number, almost 1 gigatons of CO2. Replacing diesel or petrol consumption to solar energy directly benefits the cause. Even grid benefits to the extent the mix of green energy in the grid. In Kerala, for example, 50% of grid energy is from hydro, solar and other renewable energy. Another important reason is to prevent the unburned fuel from the diesel engines and the oily bilge water from engine room to be pumped overboard. That affects the water bodies. As a commuter, if you are looking at a better ride with no noise, no vibration or smell of fuel, then also you will want solar electric system. It is more important for the crew who is constantly exposed to this noise, vibration and fuel fumes, and some of them have permanent damage to their hearing by the end of their tenure. Although safety is essential in all boats, it is crucial to highlight the importance when looking at better and more modern vessels. In many regions of the world, passenger ferry boats are subject to overloading and overcrowding, which results in accidents and loss of life. We can prevent this if the margin of stability is high in ferry boats. The margin should be 100 to 150% in carrying capacity, which means a 75 passenger ferry must be able to take 150 to 200 people safely. This can be easily achieved by building catamaran boats. When it comes to public transport system, the most crucial consideration is the Opex or operating expense. The reason is that for infrastructure projects like public transport, one can find many means of funding for capex. However, the sustainability of the project is dependent on how well we manage the Opex using the revenue. There are 4 factors why the Opex is lower in solar electric boats: efficient design, cheap energy from solar panels, low energy cost from grid stored in batteries, and low maintenance cost of an electric propulsion system. The combined effect of these 4 factors could result in a scale of 40 times lower Opex for solar boats when compared with the conventional diesel ferry made of wood or steel. Although for public infrastructure transport system, Opex benefit only need to be considered, however, for privately owned transport system, the return on investment ROI is crucial. For any transport system, we take revenue and profits to assess the ROI. Once we establish a location profitable, we can determine an alternate solution by seeing the cost. Here, one must see both initial expenditure, which is capex, and Opex. The sum of both is the total cost of ownership, TCO. In comparing the TCO of alternative solutions, the functional characteristics are similar and there is no change in revenue side. That's assumption. Solar ferry boats are 20 to 30% more expensive than diesel ferries. However, with low Opex, the TCO of a solar ferry is less than half of a diesel ferry for the 20-year life cycle. And now we have considered the battery replacement cost that comes in the 7th and 14th year as well. Let's come to the philosophy of solar boats. The functional aspects translate to energy needs due to the weight of cargo and energy to perform the function. The most significant focus when we make a solar boat is to reduce this energy need as much as possible. While the reduction of energy needs by any means is a stated objective, the deciding criteria is that the marginal benefit of the energy reduction is greater than the marginal cost, both in terms of economics. A significant factor in achieving energy reduction is by reducing the weight of the vessel. The reduction in weight decreases the power and therefore energy requirement linearly. We can meet in 3 ways. First, choice of lighter material. Some of the obvious ones are to replace the hull, deck and superstructure from steel and wood to GRP and aluminium. And second is structural optimizing. Mostly the structure design of hull, deck, superstructure are done using empirical formulas of classification society or statutory bodies. Although these are good starting point, one can reduce the structure weight without compromising the strength by optimizing the frame spacing, aspect ratio and span. Again, using FEA, we can further improve the weight reduction. And thirdly, we have to eliminate unwanted items. The trick in this step is to avoid any compromise in performance. For example, in ferry boats with a journey time less than 30 minutes, there is no need for toilets on board. Once we get the weight of the boat, that also gives a displacement of the vessel, and we can achieve this volume by working on different possibilities. And by reaching this by the lowest drag without compromising on functional parameters is usually called the optimization of underwater shape. And some of the options in that are like single versus multiple hull. A catamaran has advantages compared to single hull when it comes to stability, large area of solar panel, or large availability of passenger space for the same displacement. It also has lower drag than a single hull. Second, between a longer and a slender hull versus a shorter and fuller hull. The former is having a lower drag than the latter, and that's preferred. The third is round bilge versus chine. Here again, if you see the transverse section, round hull is typically preferred in comparison, although the construction is maybe have a different reasoning. The fourth is the rudder and appendage, which also contributes to probably 5 to 10% of the drag, and that needs to be taken care. Once a boat is electric, it is always cost effective to install maximum solar panels on the boat to make it a solar boat. There are two main reasons. The first is to get the electric energy at a lower rate. This can also be achieved by installing large panels onshore as well. The second more significant benefit is to be able to reduce the battery size, since solar energy can be produced when the boat is in motion. If we follow the energy path from its production to storage and consumption, there are losses in each steps. It also means that we can reduce the losses by using better technologies and solutions. So we can group this path in these three areas. Production includes like solar panels, charging, engines, alternator, chargers. Storage includes battery, controls, ventilation of the battery box, etc. The third consumption are these converters, motors and all the other loads. Safety of systems is the most important. It can be achieved by many means. One, by system redundancy, by having electrically independent set of propulsion units. Two, by class approval of the boat and the propulsion system. Three, by choice of chemistry, which is important. While there are many lithium chemistries, LFP and LTO are safer one. In boats, the weight of battery is less than 10% of the boat weight, hence not very sensitive, unlike the case of auto industry. 4 has multiple levels of warnings, cell level monitoring, remote monitoring. These help in improving safety. And finally, the fifth, like LSA, FFA, meeting the class standards. Let's talk of parameters. The system selection and sizing starts with these parameters obtained by functional needs, power and energy. Here, power is maximum instantaneous need in the day. The energy is a total requirement for the whole day. This includes propulsion as well as auxiliary needs. The power determines the motor rating. The motor can be inboard or outboard like pods. Again, depending on motor rating, the battery system voltage is decided, whether it's low voltage like 100 volt or medium voltage like 600 volt. Let's look at energy first. The percentage contribution from each source for the energy required is the first decision. Now the three heads are grid, sun and genset. Grid energy is stored in batteries. The energy from the sun is from solar panels. Engine usually accounts for the difference. An important element is to plot the energy balance during the operation period. This gives an idea of instantaneous energy production, instantaneous consumption, and the resulting state of charge because of this. Next is technology. Of the three parameters, that is speed, cargo weight and distance, the speed is the most sensitive. In the 75 passenger ferry, for example, the power at 6 knots is 16 kilowatt. However, at double the speed, that's at 12 knots, the power is more than 10 times, almost 190 kilowatt. The total energy for the same distance traveled is more than 6 times. That is why the boundary for making zero emission mode is about 8 knots, and beyond this speed the solution is usually hybrid. And there are two types of systems, pure electric and hybrid. Within hybrid, it could be either serial or parallel, and within parallel, it could be same shaft or independent shaft. From a system architecture, there are three types: independent, common AC and common DC. The first one, that is independent, is one of the safest with the maximum redundancy. If you need to interconnect, common AC is a simple option. It can also be done like in the DC side, like a common DC, which is mostly done in large ships with multiple generators. The exception is like Kochi Metro project, where for some strange reason they wanted interconnection on the DC side. Then there is hydrogen fuel cell. Here the issue is fuel cost. Currently it's in the range of $12 to $15 per kilogram. This does not make it economical. If the price reaches $2 to $5, as is claimed by the oil companies in India, then it becomes a very attractive option in all applications where speed, the range or the cargo weight imposes a constraint on the application to make it economical. Again, note that it is not technology limitation. Let's look at different application. As the speed of the boat, the distance it travels in a day, or the weight of cargo increases, then the complexity and ability to meet the economics is tougher. The ones on the left side are easier solutions, many of which we already executed and are under production. The ones on the right are bigger challenges under development. For the large ships, wind is a much more attractive option and can offer up to 25% of propulsion energy needs. Let's take the water taxi. It's a 10 passenger boat, catamaran, 9 meter long, 3 meter wide. The speed is 15 knots for the diesel outboard version. It could be petrol or hybrid as well. In all models, the auxiliary is run by solar. Now for more details, do raise questions or do send an email. Thank you.
Thank you, sir. Now the Q&A session is open. All visitors can post their comments in the chat box and their questions will be answered by the chairman or the concerned speakers.
Kerala has a rich maritime tradition dating back to the days of the Silk Route and even before. The ancient traditional vessels made in Kerala's Malabar coast, Urus, were the most sought-after vessels across the Middle East. Renowned as the Queen of Arabian Sea right from the ancient times, Kochi is today a cosmopolitan port city with excellent centers of education and healthcare. The city, with an overall high quality of life, is logistically well connected with the world. Located close to the international trade route, it has been identified as a strategic port for the development and ancillarization under the Sagarmala program initiated by the Government of India. Cochin Shipyard Limited, known as CSL, today is a mini Ratna company, was conceived as the first greenfield shipyard in India. It was set up in collaboration with the Mitsubishi Heavy Industries, Japan in 1969. The shipyard has advanced system of shipbuilding and today is the greenest, largest and most modern shipyard in the public sector. CSL is reputed for its unique blend of portfolio, a combination of shipbuilding and ship repair in both the commercial and defense sectors. Today, CSL has 125,000 deadweight tonnage capacity repair dock and 100,000 deadweight tonnage capacity building dock in its sprawling 700,000 square meter campus, besides 3 quays totaling about 1.2 kilometers and a slave dock. A foray made into the international market led the Yacht to export of 45 vessels including bulk carriers, offshore supply vessels, tugs, barges and specialized vessels to Europe, USA and the Middle East, which is a testimony of our stringent quality standards and timely delivery. With the first indigenous aircraft carrier project for Indian Navy being executed at CSL, India has become the 5th country in the world capable of both designing and building aircraft carriers. CSL has also built and delivered 20 fast patrol vessels for the Indian Coast Guard ahead of schedule. Under Make in India program, CSL is now venturing into the sophisticated passenger vessel segment by building 4 passenger vessels, 2 1,200 passenger cum 1,000 tons cargo vessels and 2 500 passenger cum 150 ton cargo vessels for the Andaman and Nicobar administration. A high-end technology demonstration vessel is also being made for the Government of India. The company has acquired the prized LNG shipbuilding technology with the certification from GTT France and is the first company to achieve this in India. CSL has also signed a technical service agreement with Samsung Heavy Industries Korea towards construction of LNG carriers in India. CSL is the first shipyard in India to have a robust, integrated quality, safety, health, environment management system in place and is certified by DNVGL. A motivated workforce of nearly 2,000 permanent employees led by a team of around 500 professionals and supervisors with a supporting team of 2,500 contract workmen is a real strength of the company. The team of 170 design engineers with 150 Tribon licenses puts CSL at par with the best-in-class international design facilities. The Yacht took up marine engineering training in the year 1993 and has so far trained nearly 2,000 mechanical engineers into marine engineers serving across the globe. The Yard is setting up a state-of-the-art skill development center in the background of Skill India campaign of the Government of India. CSL is strategically located close to the Cochin Port Trust and Southern Naval Command with Naval Academy at Erimala on the northern side and the upcoming Vizhinjam project on the southern side of Kerala coast. With many prestigious educational and research institutions like the Department of Ship Technology and School of Marine Engineering in QSAT, Central Institute of Fisheries Technology, Central Marine Fisheries Research Institute, CIFNet, Naval Physical and Oceanographic Laboratory of the DRDO, Kochi is fast transforming into a vibrant maritime cluster. CSL is a financially strong company with a net worth of more than 2,000 crore rupees and is consistently profit-making over the past 22 years. CSL has an unblemished industrial relations track record and is very respected for its CSR activities. CSL is also gearing up to tap the substantial possibilities in the emerging inland water transport sector and investing in a strong basic design organization. With such strong pedigree, Cochin Shipyard is now on the verge of taking up 2 major expansion projects that would strengthen the yard and transform its business. The first is the International Ship Repair Facility ISRF, which is a new ship repair facility based on 6,000-ton ship lift and 6 transfer stations to be implemented at a cost of 970 crore rupees. The ISRF, which will enable the handling of 85 vessels additionally every year and will double the existing ship repair capacity, has the potential to transform Kochi into a major ship repair hub. The second project is a new 310-meter long large dry dock being made at a cost of 1,799 crore rupees to enhance the yard capacity to construct larger next-generation aircraft carriers, large LNG carriers, cruise vessels, etc. It will also make possible the docking of semi-submersibles and jack-up rigs. These projects will be a major contributor towards making Kochi a maritime cluster. With these ambitious new projects and opportunities arising out of the Sagarmala and Make in India program, Cochin Shipyard is poised to emerge as a market leader in this part of the world and will catalyze the economic and industrial growth of India by generating more employment and business opportunities.
An unmatched record of execution and delivery. The mainstay of the Navy and Coast Guard. The largest exporter of defense vessels in India. Sculpting world-class products through in-house R&D. A clear focus on Make in India, indigenization and import substitution. ISO certified for design, construction, repairs, environment and safety. Declared the best performing shipyard in India by the Ministry of Defence. GSL is proud to make in India. Our in-house design facilities are based on the Aviva marine platform. Software such as ANSYS and LS-DYNA are widely used for design analysis. Using technologies such as artificial intelligence, IoT, machine learning and robotics, GSL is constantly upgrading and developing indigenous solutions. GSL's R&D facility is recognized as an in-house R&D unit by the Ministry of Science and Technology, Government of India. When we say we are in the business of shipbuilding excellence, we mean it. Emerging from this diverse array of infrastructure, R&D and impeccable services is a wide product range to meet the needs of both defense and commercial sectors. With exports of vessels to the Middle East, Africa and Southeast Asia, GSL is globally recognized for its wide product range, fixed costs and timely delivery.
Okay, we are live?
Yes.
Okay, good afternoon. First of all, let me introduce myself. I am Dr. Sadish Babu, and Actually, Mr. Hari from SETS was supposed to be the panel chairman, but due to some reasons, he couldn't get back from ship. So he was doing some sea trials last night. So it is my privilege to stand in as the session chairman for the first session. We had some very, very interesting and informative sessions. And we had talk about the barge design for transportation for UP government from Goa Shipyard, and passenger ferry for UP tourism by Mr. Arun Sornapudi. Then we had great case study. There's a lot of solving a big problem faced by FACT by converting a barge for carrying liquid ammonia gas by Commander Zachary sir. And we had recommendation by Professor Dr. Ananda Subramanian, and it was very interesting to see the challenges faced for the design of small pleasure crafts, and we also had a good presentation by Mr. Sandit, and we all have been following the progress of solar boards and water taxis in the media, and it's very nice to hear from you directly. So welcome to all the, we also had a good talk by Kerala Maritime Board, and representing Kerala Maritime Board, we have Advocate Tanya Mallar. So all of you are welcome to this question and answer sessions. So we have some questions in the chat box. Can I start with that, with the permission of everybody?
Yeah, please.
First question is on the LNG barge. Sir, considering the low air draft of the vessel, would a forward wheelhouse give better visibility? Did you have any other considerations which didn't allow this aspect? This is to Zachariah, sir.
Not for
so
the.
Did you get the question, sir?
Is it for me? I doubt. LNG
yes.
ammonia barge.
Considering the low air draft of the vessel, would a forward wheelhouse give a better visibility? Did you have any other consideration?
I heard the question, but is it regarding the ammonia barge?
Yes.
Okay.
Yes.
See, we were using an already existing barge, so there was no question of shifting the wheelhouse forward. We were trying to utilize best. And as there were.
Yeah, correct.
That's the thing.
So there is only one barge presently in operation, or did FACT went ahead and
at that time there were no barges, so an existing cargo barge was used for conversion. But now later on, FACT has made their own barge, ammonia barge.
Okay, sir.
Yeah.
Thank you. There is a question to Professor Ananda Subramanian. Sir, who is the owner of the vessel? Is it registered under KIV? This is from Sojan Anthony.
Yeah, thank you. I hope I am audible.
Yes.
Yeah.
Yes, sir.
Okay.
Yes.
Yeah. So I have to say that I or we, my team, we are the designers, the builders, the owners. Okay.
Sir.
It is by our company, Fine Hulls. Because with my stint of interacting with the industry, I had this passion of something different and proving that we can have a good light vessel as we have described. So we are the owners. Fine Hulls, yes.
And is it registered under KIV?
Yes, it is registered under KIV because you cannot otherwise fly the vessel. It is also under IS class.
The Padambili Turitas, it has got some other vessels also, sir?
No, we are the trendsetters. because there are vessels in and around which ply. In fact, it plies, we see it in the river every day, plying in front of us. But we hope that this will set a new trend, and therefore people will be excited with using vessels for this purpose. Yeah.
Okay, sir. Okay, sir. Thank you.
Thank you.
Now, another question to you, sir. Ananda Subramanian, sir.
Yes, sir.
What checks have been performed to ensure that the resin has infused completely at the end of the vacuum infusion process?
Right. That's a very good and very relevant question, because this whole process is controlled throughout its sequence, as I said, over the 3 to 4 hours. So one is that you are doing a test that the setting resin is setting in a time not less than 90 to 120 minutes. So the accelerator and catalyst are added under such controlled conditions. Of course, temperature, humidity are automatically controlled because it is vacuum infusion. Then the temperature is monitored during the setting process, that at every spot with a non-contact thermometer, you monitor the rise of temperature as a function of time. And if the temperature has sufficiently risen over 50 to 60 degrees and finally at even 65 degrees, it means homogeneously the setting is happening. Any other spot you will see obvious lack of setting or lack of penetration of the resin, and then you have to remedy it. Or largely in our case, because of meticulous hand holding by the parent company, Divinyl from DIAB from Sweden, we could achieve very good high quality setting. But these are typical problems that could happen, and that's how it is monitored. I hope I have answered.
Also. So yes. And you have actually brought out the improvement in the tensile strength and other mechanical properties by doing this. Like for steel, we also use some standards for testing this.
Yes, they are done under standards. It happens that IIT has an advanced composite technology center, which is recognized by IRS, and therefore the tests are performed there, but independent of this. It is done by the third party. IRS directly contracts with them, oversees the test results, and certify the acceptance of this. These are very standard tests, and they are done in a good quality laboratory, which is standardized. Yeah.
Thank you, sir.
Thank you.
Okay, now we have a question to Kerala Maritime Board, ma'am. There was a proposal that for high-speed boat service from Kochi to Kozhikode. So the question was, what happened to it? Are we going ahead with this proposal? You are mute. You have to unmute, ma'am.
Yeah, the passenger service. I think it is still under consideration. Proceedings are being taken to call expressions of interest, if I'm right.
Okay, ma'am. Ma'am, during that presentation by Mr. V.T. Matthew, there was a discussion. He was mentioning about there is a tourism division you are going to start. So can you elaborate on that? What are how it is going to, because there are so many agencies already in Kerala. So how is it going to operate? Is it independent or is it going to work along with other agencies?
I'm afraid I don't know the answer to that.
Sandit, there is a question on about water taxes. It's on how are these water taxes performing for SWTD from a financial standpoint? Because you mentioned you have made 4 boats in that. And Please unmute.
Yeah, typical Kerala state water transport boards are subsidized systems. I mean, the tickets are very low price, public transport especially. So it's like a 3 kilometer ride, maybe 6 rupees. So it's like a 2 rupee per kilometer, extremely low. Water taxis, fortunately, are directly competing with the private services. Hence, they are charging a 1 hour 1500 rupees, which is almost 75 rupees per kilometer. So you drive around 20 kilometers. Technically, it's 75 rupees per kilometer. So in that sense, because there is no subsidy element in it, and they are competing with private, they are able to make a very good revenue. So daily collection would be 7,500 to 10,000 on just, it's a 10 passenger boat. So in that sense, it's a very good return on investment from an Opex as well as CapEx point of view. It's asset utilization, like the one in Parshini-Kadavu is always booked, probably because there are not many boats there. I don't know, could be. But one in Alapura, because there are so many choices, there is, it's not as much as Parshini-Kadavu. So that is there. That's from a revenue side.
Okay. Thank you. I think Danya ma'am, I think my question was, the question actually was, there was a proposal to run 2 catamarans from Kochi to Kozhikode.
Hydrofoils, right? Those were hydrofoils?
So the question was, there was a proposal to run 2 catamarans from Kochi to Kozhikode. Is it true?
That wing in ground.
No, not big. It was a hydrofoil project. I mean, there was some class requirements, and it was lying in Cochin Shipyard for getting all the approvals. I mean, this at least a year or 2 before it was under process. I don't know what is the latest. Probably that is what he is asking, the person who asked the question.
Okay. So I think I got a warning that only 1 or 2 questions more I can take, because there are another session at 2 p.m. So Mr. Arun has come from Goa Shipyard. Can you hear me?
Yes, sir, we can hear you.
You have to unmute.
Yes, sir, I just unmuted.
There is one query to you, that the ferry was sailed from Goa to Varanasi. How many hours of engine hours were deployed? What other cost-effective method of transportations?
So, sir, I have here Mr. Ashok Naik. He is the PCM of the project. So he will be explaining it to you.
See, now what happened is we have covered more than 500 hours of main engine, propulsion engine. Okay. And it was not in a single go. Because of that Burevi cyclone, around 3-4 days we had to anchor in 2 places, right? So it has taken almost 2 months to reach from this western coast through eastern coast to Varanasi, and it has covered Arabian Sea, Indian Ocean, Bay of Bengal, Hooghly River, and then the Ganga River. Okay.
Okay. So are you planning to come to Kerala also, sir, as in our this thing? You are basically only in UP, or are you using?
No, I already come back.
Okay.
Yeah.
Okay. You have any cross questions? Your panelists, you want to ask any question to other panelists? So then we can. We have 2 minutes. We can close the session.
No, thank you.
Okay, then with permission of all the distinguished panel members, let me, on behalf of Dostas and IBMS, thank you very much for sparing your valuable time, presenting your papers, and coming live to answer the queries from the participants. Once again, thank you. Thank you very much. Have a good day.
Thank you, Dr. Satish Babu.
Thank you, sir.
Yeah, thank you. Yeah, thank you. Once again, Thank you. Thank you very much. Have a good
Thank you, Dr. Satish Babu.
Thank you. Thank you.
Thank you.